Hello everyone, Aaron here, and welcome back to Leetcode. Today we are doing the Toeplitz matrix problem. I have probably completely butchered that pronunciation. Anyway, a matrix is Toeplitz if every diagonal from top left to bottom right has the same elements. Okay. I skipped a line. Given an n by n matrix, return true if the matrix is Toeplitz, otherwise return false. So here we can see this is good because no matter what diagonal I look down, it's fine. Whereas this one here, yeah, this is a 1, 2, so that's no good. We've got bunch of constraints. This thing will never be big. The value's never going to be high. There's some follow-up. We'll come back to that. My immediate thought is the direct translation of the spec here is rather fiddly. If I see this, I then need to check all of these are equal to it. If I see this, I need to check all of these are equal to it. If I see this, I need to check all of these are equal to it. These two, this. That kind of diagonal indexing is a little bit of a pain, basically. So what we really want to do is basically just index this regularly, skipping the first row and column, and then just saying, is this equal to the diagonal thing? Is this equal to the diagonal thing? Is this equal to the diagonal thing? Obviously that row is fine. This one we know is going to be transitively correct because if this is equal to this, and we've already checked that this is equal to this, then obviously all three are good. So naively doing the indexing as specified in the definition is going to be fiddly, but we don't have to do it that way. We can go for I in range len matrix starting from 1, for j in range 1 through to the len of matrix. Well, we may as well make it I, because 0 I doesn't matter here. If matrix ij does not equal matrix I minus 1, j minus 1, so this is going from here up on this diagonal. If they differ, return false. If I make it all the way to the end, return true. This is your standard for all check, basically. You want to assert everything is true, so if any is false, if you know your formal logic, not for all is the same as exists not. That's what we're doing here. This one here, we'd start at this 2, we'd go up, we'd see this fails. M and N could be bound by 1. A 1 by 1 matrix is fine. In fact, a matrix that has either 1 row or 1 column is fine. These things start at 1, so that's handled. Let's submit it. Ooh, I should have checked it first. Doesn't matter, we're okay. Right, going back to these follow-ups. What if matrix is stored on disk and the memory is limited such that you can only load at most 1 row of the matrix into the memory at once? Oh, now that's more of a problem, isn't it? Because here we need to load this row and the row below it. We need to have, but that's not quite true. This indexing scheme here, if we can access disk fairly reliably, it depends how laborious you want to be with these particular constraints, because on the one hand we can get away with just loading 2 values in any given time. It's just going to require a massive amount of disk thrashing, effectively. We're going to constantly be loading and freeing values from the file. if we can load an entire row at once, probably best to load this row into memory and then load these rows from the file. Actually, we could probably do a sliding thing. This comes off the end, this comes on. That's our row, basically. Row plus 1. Because then when we check this, row plus 2, it's row plus 2. We would load all of those plus those 2, check those, drop that, read in that. So that's sort of a sliding window through our matrix that lets us do that kind of scan. So that's quite nice if we can load an entire row. If we can't load an entire row, basically we need that sliding window with a gap in the middle. Keep a window of however much we can hold there and a window of however much we can hold there, and just sort of sweep both row windows on each row at the same time, and that gives us a good chunk. So it's a bit hand wavy for doing these follow-ups, but it's fine. If you were in an interview and trying to answer that kind of question, that'd probably then give you a hint about what they actually mean by those constraints. So it would be, oh, well, why would you load one row over the other into memory? So why did I suggest loading this row and then reading each of these sequentially rather than loading this row and reading each of these sequentially? What was the thinking behind doing that? And at the end of the day, it doesn't really matter. It's just the only reason I was thinking that was basically if this is in memory and I'm doing a read, this is probably going to be fairly efficient, but by symmetry, that's identical. So, whatever. I'm just making noise now, so I think that's a sign that it's time for this video to end. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.